Now here we see a square. Okay, and we will be discussing all the properties of square as well. Okay, all the four sides are equal. This, this. All the four sides of a square are equal. Okay, these are the diagonals. I suppose this square is ABCD. Here AB is equal to BC is equal to CD is equal to DA. Okay, and each angle is of 90 degree. Okay, angle A is equal to angle B is equal to angle C is equal to angle D, that is 90 degree. Okay, now AC and BD are diagonals. You might have studied about diagonals in your 8, 9, 10 standard. So you must be knowing about what are the diagonals. The line that matches two points which are not adjacent. Okay, so that is called a diagonal. Here BD and AC are diagonals, and in the case of square, both the diagonals bisect each other. That is, midpoint of AC and midpoint of BD is same. Suppose it is O in this case, and the diagonals bisect each other at 90 degree angle. Okay, so these are the basic properties that you have to keep in your mind. Okay, now what is the perimeter? Since all the four sides are equal, suppose I assume the side to be A, so the perimeter will be 4A. Okay, so perimeter is 4A, and similarly area will be A square. If the side of the square is A, then the area will be A square. Okay, and what will be the length of diagonal? That also we can find out. You must be knowing about Pythagoras theorem. Pythagoras theorem is used for a right angle triangle. I just show it over here. In a right angle triangle, this angle is 90 degree. This is known as perpendicular, this is as base, and this is as hypotenuse. Hypotenuse is the biggest length in any right angle triangle. Okay, and perpendicular and base make an angle of 90 degree with each other. Okay, so what Pythagoras theorem is? It's p square plus b square is equal to h square. P square plus b square is equal to h square, and it is very important. Various questions based on Pythagoras theorems come in examination. Okay, so it's p square plus b square is equal to h square. So if any two quantities are given to us, we can calculate the third one. Since three unknowns are there, we can calculate the third one if two are given to us. Okay, so in this case, suppose we have to find out the length of the diagonal. How do we do that? Wait a moment. Now we see here a right angle triangle ACB. Right angle triangle ACB, that is right angled at B. That means angle B is 90 degree. I assume the length of AC, that is diagonal, is D, and we have to calculate the value of D. Okay, so D square, that is hypotenuse square in this triangle, will be equal to perpendicular square plus base square, that is A square plus A square. So 2A square is D square. So A square is 1 upon 2D square. I'm sorry, D square is 2A square. That means D is equal to root 2A. That means if you are given side of a square, you can calculate the length of its diagonal. That will be root 2 times of its side. Okay, so these are the basic terminologies related to a square, and we will be discussing problems and more properties whenever they are required. Okay, and just keep one thing in mind: n square can inscribe a circle. That means we can draw a circle that touches all the four sides of the square. I just show it over here. This is a circle that can be inscribed in a square. Okay, and even a circle can inscribe this square. Okay, so we'll be discussing more such properties later on in the session. So till now, I hope you are clear. Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss about various shapes. Okay, we will be taking 2D shapes, that is two-dimensional shapes and three-dimensional shapes, and we'll be discussing various terminologies uh, related to this. All these shapes. So we'll be discussing their area, perimeter, various types of triangles, various types of quadrilaterals, parallelograms, and the 3D shapes. Maybe we will talk about cylinders, cones, spheres, and all that. Okay, so precisely it will be a lengthy series of the sessions, and you can call that the series of session name is mensuration. Okay, so let's take the shapes one by one. First of all, we will be taking 2D shapes, that is two-dimensional shapes. Then we will be taking three-dimensional shapes. Okay, so let's take the shapes one by one. Now we see a rectangle. In the case of rectangle, the opposite sides are equal. I suppose this rectangle to be A, B, C, and D. And this is the intersection point of both the diagonals, that is O. Okay. Now, in the case of rectangle, the length of opposite sides is equal. So if it is A, it will also be A. If it is B, it will also be of B. But both of these lengths will be different. If both of these lengths are same, then it will turn to a square. Okay. So specifically, if we talk about rectangle, only the length of opposite sides are equal. Further, the diagonal bisect each other, but this angle is not 90 degree as in the case of square. Here it may be any other angle. Okay, so just write the perimeter. That will be A plus B plus A plus B. That means 2 times A plus B. Okay, and what is the area? Area is product of sides, that is A into B. Okay, so it will be in linear unit. I mean to say meter, kilometer, centimeter, something like that, and it will be in square unit. Maybe meter square, kilometer square, centimeter square, or square feet. Okay, but it will be in square units. Now, how do we find the length of the diagonal in this case? Further, we can approach for Pythagoras theorem. Suppose this length AC is the diagonal B. Okay, so in this case, ABC, it's a right angle triangle. So definitely A square plus B square is equal to D square, where A and B are the lengths of the rectangle. If you know the length or the sides of the rectangle, you can calculate the value of the diagonal, or you can calculate the length of the diagonal. Okay, so these are the basic terminologies related to a rectangle. Now, in this case, please keep this thing in mind that a rectangle cannot inscribe a circle. Okay, if I wish to draw a circle, it will touch only two sides or maximum three sides of a rectangle, but it cannot touch all the four sides of a rectangle. Okay, you have to be very clear about it, because various problems based on this particular property come in examination. Okay, so I hope you are clear about rectangles. In this case also, I forgot to tell you one thing. All the four angles are of 90 degree. Okay, and in all, sum of all the angles will be 90 into 4, that is 360 degree. Okay, so in the case of square, the sum of all the angles is 360 degree, and in the case of even rectangle, sum of all the angles is 360 degree. And definitely it is true for all the quadrilaterals. Whatever the shape they are having four sides, a closed figure of four sides will always have the sum of angles as 360 degree. Okay. Now let's discuss about triangles. A triangle is a closed figure with three sides. Now, these three sides may be equal, maybe not equal, and maybe two sides are equal and the third one is not equal. So there are various types of triangles if we talk regarding this sides. If all the three sides of a triangle are equal, then we call it as an equilateral triangle. Okay, if the three sides are equal. Then we take an isosceles triangle. If two sides are equal. And the third one is scalene triangle. If none of the sides are equal. Okay, so these are the three types of triangles: equilateral, isosceles, and scalene. But in every case, the sum of the angles will be 180 degree. Suppose we talk about any triangle A, B, C, whether it is an equilateral triangle, it is an isosceles triangle, or it is a scalene triangle, the sum of the angles will be 180 degree only. So angle A plus angle B plus angle C will be 180 degree. Okay. There is other discrimination also if we talk about triangles, that is acute angle triangle, obtuse angle triangle, and right angle triangle. So let's discuss that. Now, as I told you, the sum of the three angles is 180 degree. Okay, now suppose I take this angle A, B, and C. Now, if any angle of a triangle, if all the three angles, if all the three angles are less than 90 degree, angle A, angle B, and angle C are less than 90 degree, then we call it as an acute triangle. Okay, if any one angle, only one angle, more than one angle cannot be more than 90 degree, because the sum should be restricted to 180 degree. So if any angle is greater than 90 degree, then it is obtuse angle, any angle. Okay, and if a single angle is equal to 90 degree, that means only one angle is 90 degree, then we'll call it right angle triangle. Okay, so this is also one sort of discrimination: acute angle triangle, obtuse angle triangle, and right angle triangle. But above all, the important thing is that the sum of all the three angles should be 180 degree. Okay, so the other thing is how to calculate the area and perimeter of various triangles. So let's come on that. Let's now discuss the various formula for to find out the area of a triangle. The first of all is area of a triangle if the length of the base, that is, suppose in this case if we talk about this is base, suppose the length of the base is maybe C, if it is given, and this is altitude, I suppose it is point P. So CP is altitude. Altitude means a line from the opposite vertex on the opposite side is called altitude. It makes an angle of 90 degree with the base. Okay, so this is an altitude. Okay, so in this case the area of the triangle is half base, that is C, into altitude, whatever the length is, I suppose it is L. So it's half base into altitude. That is the simplest formula to find out area of a triangle. But in case you are not given the altitude's length, then how do you find out the area? In that case, suppose you are given the length of all the three sides, then also you can find out the area of the triangle. Now how do we do that? Wait a moment. Now, the other formula to find out the area of a triangle is Heron's formula. In this case, suppose all the three sides if given to us, suppose it is A, it's B, and it is C, then we can calculate the area of the triangle. First of all, we have to calculate semi-perimeter of a triangle. So semi-perimeter S is, suppose I assume it to be S. So it with the value of semi-perimeter over here is half of sum of the sides, that is A plus B plus C by 2. Okay. So once we calculate the value of semi-perimeter, we can calculate the value of area. Area of a triangle will be equal to square root of s, s minus a, s minus b, s minus c. Okay, where s is the semi-perimeter of the triangle and a, b, c are the lengths of the triangle. So if we know all the three lengths, we can calculate the value of semi-perimeter. Then if we put the values of all these four terms over here, we can calculate the value of area of that particular triangle. Okay, now if this is the case when we're discussing we're discussing is the area of a triangle where all the three sides are not equal. Okay, if the two sides are equal or maybe all the three sides are equal, the formula will be changed accordingly. Suppose all the three sides are equal, then the value of b and c will also be same as a. That means all the three sides are equal. So we can calculate the area of an equilateral triangle by putting the value of b and c as a in the same formula. So what that will be, just hold on. Suppose I put b and c also a, so s will be 3a by 2, that is a plus a by 2, that is 3a by 2. So I put the value of s and the lengths of sides in this formula. So it's 3a by 2 into 3a by 2 minus a will be a by 2. 3a by 2 minus b, as b is also same as a, so it will be a by 2 and it will also be a by 2. And there's a square root. So if it comes out of square root, it will be a raised to 4, so it's a square, then root 3, but it's 2 raised to 4, so if it comes out of the square, it will be 4. So it's root 3 by 4 a square. If it is an equilateral triangle, this formula is for to calculate the area for an equilateral triangle when all the three sides are equal. Okay. Now, let's discuss one more formula for the calculation of area. Now the third formula for calculation of area of a triangle is sine formula. You might have studied trigonometry in your junior classes, maybe 9th standard and 10th standard, and you might have studied about the 6 trigonometric functions, that is sine theta, cos theta, tan theta, cot theta, cosine theta and sec theta. Okay, so here we'll be using sine formula to calculate the area. Okay, now what is that? Suppose between these two sides an angle theta is there. Okay, between these two sides, then the area of triangle will be half a into b into sine theta. Okay, that is the angle between these two sides. So product of the sides and sine of the angle between the sides. Okay, similarly, if this angle is maybe x and this angle is maybe y, so the area of this triangle can be calculated as b into c into sine x. Okay, that is product of the sides into sine of angle between these two sides. Similarly, it is half a into c into sine y. Okay, so any of the formula we can use depends upon the datas given. Okay, so we discussed about 3 formula for calculation of area of triangle. The previous twos were like very common. This is something, it's not very common, but in CAT examination, the problems based on sine formula are coming on regular basis. So you should be knowing this. Now, the next thing is perimeter of a triangle, that is sum of the sides. So whatever the sides, length of sides is given to you, we just add them up and you'll be getting the value of the perimeter of a triangle. Okay. Now one more important theorem over here is inequality of sides. Okay, or we can say inequality theorem. Problems based on inequality theorem are also coming in various examinations. And what is that? That is sum of any two sides of a triangle is greater than the third side. Any two sides we can talk over here. Suppose I have AB plus BC. The length of AB and BC combined together will be greater than the third length. Similarly, AC plus BC will be greater than AB, and similarly AB plus AC will be greater than BC. So this is the inequality theorem for triangles. Let's now discuss one or two more common terminologies related to triangles. Suppose I have this triangle A, B, C. Then this suppose the lengths are A, B, and C. So here AP, BQ, and CR. Here AP, this is 90 degree, and here it is 90 degree, and here it is 90 degree. Here BP, CR, and AP. I'm sorry, BQ, CR, and AP. These are known as altitudes of the triangle. Okay, that is a line drawn from this vertex to the opposite side, and that too of 90 degree with the 90 degree angle. Okay, so these three are altitudes of the triangle. And the point of concurrence, that means the point at which all the three altitudes are meeting, as orthocenter, as known as orthocenter. Okay, so this is also a terminology related to triangle. The concurrence point of all the three altitudes is known as orthocenter. Okay, the second thing is median. Now what median is, suppose this is a triangle ABC, and this is the midpoint of this triangle. Suppose it is X, and the midpoint of this particular side, suppose it is X, and midpoint of this side is suppose Y, and midpoint of this side is suppose Z. Okay, so a line drawn from opposite vertex, from a vertex to its opposite sides that bisects that side is median. So suppose this length, this point is X, this point is Y, and this point is Z, and the length of this complete side is BC. Here it is AC, and here it is AB. That means this is BC by 2, and this is also BC by 2, and AX is median, BY is median, and CZ is median, and point of concurrence of median is centroid. Okay, so it's centroid. So these two are the common terminologies related to triangle, apart from the basic one. Now let's now discuss the other things also. Friends, you can see an image over here, a picture over here. We have a triangle and we have a circle. The circle is drawn in such a way that it is touching all the three sides of the triangle. Okay, so this is the circle that is inscribed in a triangle. Okay, that is touching all the three sides of the triangle. Similarly, here we see a triangle that is passing through the vertices of the, here we see a circle that is passing through the vertices of the triangle. That means here this circle has circumscribed the triangle. Okay, so we can draw this sort of circles. Friends, we have discussed various terminologies related to various shapes in this session. Still many more are pending, so that we will be discussing our next session. Do revise this session before coming to the next session. Bye-bye.